Well, another month has gone, and look at this. Almost the end of the year. So, this is the Secchi September month in review. In this, we're going to see what that X20 flare looked like, and it was something to behold. We're going to be looking at some strange objects. And are those ships that we see out there? All right. Just for review, understand that only A is working, B is out of commission. So all the footage that we will be seeing is from A, but I do have at the end of the video a very interesting archive from B. So I'm going to tell you right from the beginning. I'm going to postulate a new hypothesis. I have been following Secchi for a long time. I have every one of the months starting back in 2006 of December, each one in a protected data file, external, may I add. So I've looked at this extensively, been working on about a 6-month project on the history of Secchi from an observer's point of view. So now that you can see where we are, and so to understand the reason why we see Venus and Mercury so often in these shots is that it's because of the view. Now, if B was over here, we'd be seeing many times Mars, Jupiter, and Saturn. We see those over here, but for the most part, you're going to see Venus and Mercury coming into view quite often. All right, so here we go. Now, this was September 2nd. We had just finished the eclipse. So everyone was kind of in tune to what, was going on. All of us who look at the satellite data, well, we always wait till we can get all the frames and also see all the frames that they took out. All right, so here is typically what we will see when there is a coronal mass ejection, whether that be from, a flare, or it could be from a filament release. And you can see how Secchi catches that. And by the way, when you're looking in this light spectrum here, folks, that is just enormous amount of energy. This is Venus right in here. You can see when the sun lets loose, it can let loose with some force. So this is the 6th. All of a sudden, we get this anomaly. Now, I have seen this anomaly before. Now, you can just see that the optics of the camera, this is the solar flare that hit us, folks. And if you recall, back there on the 7th, 8th, and all the way until that final group was really getting to where it's 90 degrees of where the Earth was facing, was continuing. In fact, that's where the X20 flare took place. So what you're seeing here is just the optics of this camera just being overwhelmed with the photons. Now, I want you to pay attention to the time code down here, right? So I'm going to show you how this very well could be the sun. The anomaly is yet to be fully explained, being that if this is what the camera, and the camera is not pointing at the sun, it's pointing off to it. So what we're seeing here is the camera looking out, and this is still caused by the sun. All right, time code. We're well into this thing with 4 or 5 hours. Look at this. So, just knowing a little bit about optics, the question I have is that we're going into a 2-day event where if this is an anomaly of the camera due to that flare that came out that overwhelmed the optics, and if it's like with our optics, when you get a bright flash, you're going to see that outline of the flash. Many times you can actually see if there's an object nearby. So if this is what we're seeing, okay, I get that. Um, would it be a prolonged event? Well, kind of depends. I have seen in the archives that it lasted for a couple of hours. This one is lasting for a couple of days. Now, this is a different camera pointed out towards the outer solar system. Out here, we will typically see Jupiter, we'll see Saturn, and of course, this is the sun here. All right. Now, I can't explain this. I really can't. This object, this camera should not be having any type of a after image reflection issue. It just shouldn't. And why it's picking this up, I don't know. And this was actually one of the first ones I've actually seen from this perspective. And you can see um, huge. This is just huge, folks. The best I can explain it to you would be if we were to measure this, probably be the complete diameter, excuse me, of the inner solar system. I mean, that's how big we're talking about. Here, I went in and used some filters, and you can really see that this is, in fact, like I said, this is the first one I have found of this nature, and there it went away. So we can actually go back and you can see the time code 9622, 962009. So this one only lasted for a couple of hours. And I said, I've not seen an anomaly such as that. Now, this is going to, as you can see up here, stereo A H1. So this one gives us the perspective of seeing both positive and negative charged ions. All right, that's what you're seeing here. And it's a great camera, but boom, there's the money shot. So I'm picking this up now on 4 of the different cameras that are working. Now we're going to do some analysis because if we're seeing the sun, then we've got to begin to ask ourselves, well, what is this right here? And as you can see, if this is a light issue, the light would be showing up in here. It wouldn't be actually making an impression like this. And I used a couple of filters, and I guess you could say, well, this could be what we're seeing as the fusion on the sun. But yeah, okay, then what's happening over here? And still, we're getting, you know, something happening up here near the poles. Another filter. And now you can see the sun flaring. This is about the time the first flare hit. So here, the anomaly is this. We shouldn't be seeing this. We're actually seeing this before the solar flare. Uh, that one, and I've been giving this some thought, and we're getting some very odd anomalies here. We're getting clear contrast of both positive and negative ions. Again, you can see the time code down there. This is the camera itself. Pay it, once again, look at the time code so you can have this for your own reference. This camera shouldn't really be seeing this. And these are literally taken right off the frames from the satellite. And this one is the strangest. Remember the one I showed you earlier? We're looking out in the outer solar system. And again, if this is a malfunction happening with all of the cameras, well, I don't know what the odds of that to be happening would be. We always try to find the most rational to all the explanations. And you can begin to get an idea that if we were to measure this, it is just huge. Now, this is the one I don't understand. Huh. Shall we put this at number 3 or 4, right? The optics of this is being overwhelmed. All right. So let's say that this is, in fact, when we had the X class flare hit us, went off. Problem we have here is the optics are being overwhelmed from the rear. This is deep space. And you can begin to see how this anomaly is picking this up. Such interesting definition, isn't it? Now, you see what I'm talking about? The sun's over here, folks. See where my pointer is? Over here. Now, you could argue and say, well, the camera reversed the image. Yeah, but that argument falls apart here in the next frame. So I don't know what's happening out here in which would be away from the sun. Now, you see where I said your argument doesn't work? Because right here, we're now picking this directly off of the sun. This is the ejecta coming off of that flare. And here I went and grabbed some frames so you can see exactly what's taking place here. So it works for reversing, except the flare isn't reversed. And these were exactly the sunspot grouping. So we have an anomaly in all cameras, lasted for days, although close, not a match. So this is a wild thought. Could this be, who is it, Rocco? Is this the dark sun? Is it the fact that maybe and just maybe that there is in fact something else out there? I mean, it's a weird anomaly. So I'm going to show you some more interesting anomalies as we go forward. Now, this is the first CME that went off, and you can just see how this camera picks up just the positive negatives. I mean, look at the shock wave on this thing. I mean, folks, that's Venus right there. That's a bad day. Been a bad day for the Earth had we been caught in that. Look at the enormity of this ejecta. And you can just see, look at how it's bunching up here. And this is what you learn that I've learned, thank you, Ben Davidson, from Suspicious Observers. This is how we can actually see the impact of coronal holes, the coronal hole stream coming at Earth, and how many times if you have a CME with a coronal hole, that you can see how it's bunching up. It slows down, and it's actually like a snow shovel. As you continue to push, you're just building up ions here. So, and this is the Birkeland current. All planets actually have a current. And you can still see the shock wave. And by the way, this is tens of millions of miles. Now, this is an anomaly. What are we picking up here? That's light. Just another crazy theory. As an airplane creates a wake, as a boat creates a wake on the water, could a propulsion system that is using an energy such as this, listen, that's energy, folks. And think about it. If we had the knowledge, we could actually capture that, manipulate it, and use it for a transportation, an engine. So are we seeing something in here that's using photon technology? And what we're seeing is the wake? Yeah. Now, the problem with this is that here's the sun right over here, folks. Look at this. And this is what the camera is picking up. Are we seeing possibly an intelligence, a species that knows how to use, let's say, photon technology, having a propulsion system that is beyond our comprehension? Now, these we know are coming off of our star. There's our object again. Now, this one even gets a little weirder. What's going on here? We're going to spend a second on this one. There's clearly something here. Clearly something there. And more curious is this over here. Look at this. I mean, there's clearly something there that's what we're seeing. That's what I love about this camera. But we're also seeing something really big out here. I don't understand the 90-degree turn there. But, and then this was that X20. Listen, we don't know what it was. We didn't have any instruments that could measure it. We just know it was bigger than the one that hit us. And you can see here by this enormous shock wave that is going out from the sun. This was a halo effect. And you can just see the photons. It's going crazy, folks. I mean, this is just, it's on a level of a magnitude of expulsion of energy we can't conceive of. We can see it, but even our brains are not going to compute this. Now, imagine if you had the intelligence, you had the knowledge of how you could begin to wait for one of these events and then use that energy. This is a lot of energy. I believe one day mankind will gain the knowledge to how we can absolutely capture the energy of the stars and use it for a propulsion system. I think we could use it as free energy. You'd never have to see no more fossil fuel. Absolutely, that's gone. You wouldn't have to see the inefficiency of wind turbines, and particularly the inefficiency of solar collecting. This would so far exceed it, and it would power our planet indefinitely. And I'm just showing you the enormity of this. I mean, again, tens of millions of miles. Now, here we have new objects. Look at the time code. See, I'm convinced that we're seeing something here. I mean, you can argue with me, but why argue? Just give me your thoughts. I've looked at this for years and have pondered this. And the only thing I can see is that I see an airplane wake. The same thing that a plane would move through our atmosphere. You could almost see it as well as a ship, a boat. Same thing here. Now, I thought, well, you would have an enormous craft. No, not necessarily. I mean, a wake expands behind the force of the object that created it. And look at this when you get it into the negative part of seeing what's going on, the trails. There's a faint one up here. Now, this shows you that when the CME went off, how it will affect the camera. Look at the time code. This is just a couple of days ago. And on this one here, maybe is caused by that ejecta. Not sure. But then this gets crazier. I mean, here we got a shock wave going out. That's what this is. We've got something going on here. And look at this. When do photons make a UE? I don't know. This one here, if you study it, it gets interesting. I call this the barrel roll effect. I mean, this is just raw energy. You don't want to be near this. And more. Again, just the enormity of this is just mind-boggling. These are planets, objects. We're looking out into deep space. And here I took that picture we had saw earlier and really broke it down into better light spectrums. Look at this, folks. Whatever this is, it's creating a void out here. And again, I don't know if we're capturing the object here that caused this. And again, look at here. This is a clear delineation of the background light. These are stars. This is looking out into the Milky Way. Yeah. And then I put it through a lighter, and here you can really begin to see what is that. I mean, it's very bizarre. And again, is this what's causing this? Not sure. Taking it into another light. Now, this object clearly becomes much more defined as it is over here. So the diffusion of the star field tells us that this is being obfuscated by something. Same thing here. Lessening it, taking out the light, and now you can clearly begin to see. Again, these streaks. I keep on thinking that every star out there has unique compositions. You can have a red dwarf, brown dwarf, white dwarf, yellow dwarf. You could have any type of class of star in its age. Each would throw off, I would imagine, if it's of the same age and same class, you could then pretty well predict on a star map, if you were traveling the universe, which particular stars you would need to intersect with in order to make sure if you had to have a refueling situation. This is what I've come to the conclusion of. Because sometimes you just never know what it is you're actually seeing. Sometimes this is a species saying hello. Oh, yeah. We've caught them on multiple cameras, multiple satellites, multiple directions, multiple light spectrums. Something's out there. Now, this was from 2010, January. Camera anomaly? There were no flares on this one, folks. So we can't say it was caused by overwhelming the optics. Computer malfunction? I don't think so. Nope. Something else. Things that we don't quite understand. Things that we don't sometimes want to actually accept. The only problem is there's something out there. And I think there's a lot of something out there. So, what is it that we're seeing? Well, I'm not sure. I do know this, that it certainly seems that something's out there. Well, I hope you enjoyed this month in review of our friends Secchi. Well, can't wait till next month. All right, folks, be kind to one another. We'll talk soon.